Good morning, welcome, and thank you for joining us. My name is Dwayne Henderson. I'm a member of Cree Lighting's training and education team and host of our e-learning series. For those watching live, happy Wednesday. Quickly about the session, once we get going, it'll be about 15 minutes of content. The presenter will stay on the line for Q&A. Although the attendees are muted, we do encourage you guys to participate using the chat or Q&A box to ask questions. Feel free to ask those during the event, and we'll circle back at the end of the event to answer any questions we get. As you know, Wednesday is industry-related content, and today's session will gain more insight on LM-79 reports. To walk us through that, I'd like to welcome John Vollers. Good morning, John.
Good morning, Dwayne. Hi, my name is Jonathan Vollers. I'm the technical manager here at Cree Lighting for lighting qualification and photometry, which kind of relates to any performance-related specifications. So DLC, Energy Star, I help submit for those. I also run the photometry labs at Cree, and it's one of the critical items supporting those programs.
Perfect. All right, well, let's get started.
There we go. All right, so today we're going to talk about the LM-79 report, which has kind of come ubiquitous with a photometry report, but in particular, it's actually only applied to solid-state lighting lamps and luminaires. This is a laboratory measurement specification that is generated by the Illuminating Engineering Society, and I happen to sit on the test procedures committee, write this and update it as industry needs. The two main components of the LM-79 procedure, which generates data for the for photometry, are the integrating sphere on the left, and then the goniometer on the right. On the right, in particular, this is a Type C goniometer, and the luminaire would be sitting in the middle of the room there, and the mirror would traverse around it. And the camera right now is actually acting as where the photo detector would be roughly measuring the light. So these two pieces of equipment which support the LM-79 procedure give us different bits of data. So the integrating sphere in particular is a great way of providing just total luminous flux. So how much light the luminaire produces, the color coordinates of that light. So what color, where does it sit? You know, is it a little bit reddish? Is it warmer? Is it brighter? The color temperature of that light. Also the color rendering index and the TM30 metrics. This is all generated from the spectral power density, or the different wavelengths that the luminaire generates. Down in the graphs below, or the graphics below, you can see on the left there, when the luminaire or lamp is in the center of the sphere, that's actually what's called 4-pi measurement. And then on the right, it shows the SSL product being lit from the side of the sphere. That's actually called a 2-pi measurement. And it's really just related to the type of calculations that go into actually generating the total luminous flux. But ultimately, the light is distributed within that sphere and then goes into the detector, and there's measurements made to generate that data. On the right is the goniometer, and that goniometer really looks at the distribution of the light, not just an integrated total of the light. The way that does it is the luminaire does rotate on its axis, and then the mirror actually moves around and measures at different points to create this table of what we call a candela table, which creates our plots, our polar candela plots, understanding illuminance, the beam spreads for floodlights, and the big output from the goniometer is the IES file, which that is a tool that it's a general text file that can be put into software analysis like AGI-32, and you can do room layouts based on the different luminaires that you've selected. Super important. Some of the other things that come out of that file are the coefficients of utilization, again, a tool for layouts, what luminance data, how bright the luminaire might look, and then the unified glare rating is a newer one that's coming along, a newer metric. You can also put a spectroradiometer, meaning that it's a spectrometer that measures color as well as intensity. And then you can get color over angle, which can be helpful when understanding a wall wash and whether you get some color separation. But in general, that type of color measurement takes hours, meaning upwards of 8 hours long to measure that much data. So in general, the most common use is getting color and total luminous flux and that data from the integrating sphere, which might take 45 minutes to an hour for a measurement. And then on the goniometer, using just the photometer, getting intensity only, and that takes maybe an hour to 2 hours, kind of depending on how long it takes to stabilize the unit. The output of that generates the report. And so most of the time, what you'll see from an LM-79 report is you get this general performance data is usually the most critical, or at least what most people use an LM-79 report for. We have luminous flux, which again is the total light output of the product. The efficacy of the product is a calculation based on the total luminous flux divided by the power it took. So it's a good way to evaluate performance of one lamp or luminaire compared to another and how well they're using the energy that we're providing it. Obviously super critical for DLC, for Energy Star, for any energy efficiency program. That's one of the critical items that is utilized. We see here this particular product is a color temperature of about 4,900, which really falls in the 5,000 Kelvin bin. And then it has a color rendering index of 92. And then here we see an R9 of 67. So this is a metric that's been brought forth. It's kind of a supplementary metric. It denotes red and how well the product produces red color in the space. And so that R9, anything above 0 is considered good. And so that's something that's displayed a little bit more prominently here. And then we have our electrical measurements. That's very important because we're trying to understand what type of, how much power we're using, what the voltages that the product is used at. In this instance, we measure the 120 volts, and also it's a universal driver, so it can be run at 120 or 277 volts. The other important aspect, especially to utilities, is they care about the total harmonic distortion, which relates to how much noise is being generated by that product out on the line, and could cause some problems if they allow that to be too great. So that's certainly important to utility programs and things of that nature. Getting into some of the color characteristics that are usually in graphs that are usually represented in an LM79. So color basics. We have the color coordinate system, both X, Y, and U prime, V prime. Those are displayed here. They're just different ways of looking at a product in the color space that we see. And then on the right, you can see here how those color coordinates are plotted out, showing CCX, CCY is X, Y, and Y. And you can see the black body curve. That's the perfect white light, if you will. And you can see how close that green dot, and that's the particular luminaire we're looking at here, is right on that black body curve. And in this instance, it's a 3052 Kelvin product, and you can see that it clearly falls well within the 3000 Kelvin quadrangle, which is an ANSI defined space to kind of help group the color of light of different products. And then back on the left here, we see the color rendering index. Again, the CRI is really an RA, that 84 right there. And then that is the average of R1 through R8. And then you can see again here, this displays R9, and it also displays up through R14, which just provides some extra color information for somebody trying to specify, maybe they have different, reds that they want to emphasize or different colors that they want to emphasize. This helps define that to them. And all that is generated out of that spectral power distribution. If you look below, this graph should be pretty typical in LM-79 reports. You're seeing the light broken up into the different wavelengths that it's actually generating. Solid state lighting typically is a blue pump. So you can see that big spike at about 450 nanometers. And then the phosphor converts all of that blue energy, blue wavelength, and it spreads it out over the visible spectrum. So you get your greens, your yellows, your oranges, and reds. So this is really critical in basically being able to display products and the room and environment in an appropriate color manner. You're getting good, you have to have the light, you have to have the color in the light to be able to reflect appropriately. So this is a great way to compare products and should be in every LM-79 that you would see. And then kind of going into the next generation of products or next generation of color metrics, we see TM30. TM30 takes that spectral power distribution and then puts the reference against it. And you can see that line up in the left-hand corner. And then we create maybe a little bit better color reference because we're using, instead of that R1 through R8 sample, we're using 99 color references. So now we're getting a better, broader spectrum, a better comparison across color references. And the fidelity of that light is shown as a 92 on the left down here in this color box. And then we have a 102, meaning 100 is the best or perfect. And our fidelity is very good. And then we're actually oversaturating. The RG is when you saturate light or make it more vibrant. So these are metrics that are going to be or are added to LM-79 reports to help define the color a little bit more and in a little bit more in depth. But again, all that is generated out of that spectral power distribution. And on the right, you can see here 360 nanometers all the way up to 830 nanometers. It just shows you the different powers that are at that different wavelength. Obviously, one of the other important items out of an LM-79 report is the light distribution, and we get from that Goni photometer. So probably one of the most common examples of that is the Candela plot or polar plots. So here we see on the left is an indoor example, and on the right is an outdoor example. And sometimes these are a little bit hard to understand because we're seeing these red and blue lines, and what do they mean? So what I did here is I added a representative luminaire, and what I'd we're looking at it from the side view. So now we see on the indoor example on the left, assume it's a linear ambient, and we're looking at the end of it. And you can see that nice Lambertian distribution distributing down with the blue line that's being graphed. And then on the right, this outdoor example, we have the luminaire on this, looking at it from the side, and you can see the blue line is throwing, that luminaire is throwing that light forward and down, trying to create a distribution, in this particular application is probably a roadway. You're looking at a 2 to 4 lane highway, and you're trying to throw that light from the side of the road all the way out. And then we take and look at the red plots and understand what angle we're looking at, what view we're looking at here. So here we're actually looking at the top view. So now, on the indoor example, we see that the luminaire is producing a nice even light. Again, that Lambertian downward light is producing a nice even light all the way around the luminaire itself, which is what we want from an indoor application. And then the outdoor application, we see how it's throwing the light to the left and right. So we understand from the blue graph, it's throwing it forward and down. And on the red graph, we're seeing how well it's throwing to the left and right. So that helps with, in an outdoor example like a roadway, it would help keep the pole spacing far enough away so you're not having a luminaire every 10 feet. You're really trying to space that out, have the least amount of luminaires and poles, but still getting good uniformity and even distribution across the roadway. Now we take that data and we get into some of the application-specific information that can be in an LM-79 report. And on the left here is an indoor example of, how someone might use coefficients of utilization, which is a tool to understand how much light will be on a task surface. The luminance data, how glary or how bright the luminaire might look to the eye. And then kind of this new generation, a UGR table might start appearing in LM-79s, which is really application specific. And it's something that's come out of Europe and has only started to be adopted in the United States, particularly by the DLC, to try and understand better performing glare products, and how glary something might or might not be in an application. So it's the value of, say, 23 or 22 might be good for a troffer. It might be different for a high bay. So it's all application specific, and you can apply it to your room that you are generating or looking at to design for. On the right is an outdoor example, and now this, we see the type of information that we'll provide in an LM-79, where we're trying to understand how an area luminaire roadway might be used. We want to understand the street side and the house side. So how much light is being thrown where we want it on the road, and maybe to the house side where we don't want it. So you can see here in the right, the light is being thrown towards the road, and there's very little light going towards the house side. So that way we're not getting light trespass. And one of the other critical metrics that come out of this is the bug rating, which is really backlight, uplight, and glare. And glare really being high angle light. And they're just trying to understand that as you're driving down the roadway, if you look up and see the luminaire, the next street light, does it bother your eyes? So that's high angle light or glare. So these are some of the items that come out of an LM-79 report and why they're there. Each lab might put these together in a slightly different way, but ultimately this data should be in and represented in your LM-79 report. All right, and that's all I have for today. Dwayne, do we have any questions?
Yeah, we do have a question. There was a question about, we were showing the upper and lower constraints of the quadrant angles, and there was a question about if that represented one step off the macadams, the macadam steps in terms of accuracy to white. I don't know if you might want to talk about what within the LM-79 report, if somebody's worried about color variation, what within this tool can help us find that. Yep, I think that's where you're at.
Yep. So the quadrangle is effectively 7 macadams. Obviously, from the black body, if you move plus or minus so much distance, after that, the concept is that beyond that, ANSI has defined it as that's not in that color scope anymore. So you're getting that shift that is too far, and you can't really call it a 3000 Kelvin product. Or more importantly, maybe one unit is right in the center and one is beyond that, that quadrangle. You would tell the difference color wise, and one would look more white, and then one would actually start being to the point where you really define it as a colored luminaire. Do you think that answers the question?
I think so. If not, hit us again, Neil, if we need more clarification on that. John, wondering that the LM-79 reports, I'm guessing there's some required information. You talked about DLC and the information that they're after, so there's similarities. Are they all going to look the same from manufacturer to manufacturer, or there's some variation?
There is some variation, but ultimately LM-79, the actual laboratory measurement specification or procedure requires, chromaticity, requires power, requires total luminous flux. So there should be consistent things that are in each report, but a lot of times laboratories have, if you're an internal laboratory to a manufacturer, you're going to work with your marketing department or your customers and generate a report that satisfies kind of what market you work in and maybe what's more important. And if you're a third-party lab, maybe you have a largest customer that's a lamp manufacturer and they want their order of the data a certain way. So that's why a lot of the reports look different, or they have different headers and they might have organized differently. But that data should be very, very similar. And the expectation based on accreditation and the way that we run our laboratories is that you could take a lab or a luminaire or lamp and send it, and you would have a very minor difference between our measurement and another lab's measurement.
Cool. So we had Neil got back to us, by the way. You did answer Neil's question, so we're good there.
Okay.
What is the difference between an LM-79 and an LM-80 report? So just to real quickly on that question, our next session actually will be with John again next Wednesday, and we're actually going to look at LM-80 reports and LM-21 reports. So I don't know if you want to tease that a little bit, John, knowing that we're going to do a deeper dive next week.
Sure. So an LM-79 report is a static, initial photometric report of a product. An LM-80 report is it's at the LED component level. So it's a much, if you think about LM-79 would be maybe looking at a lamp or a luminaire, so an integrated full system. LM-80 looks at the component level, the LED level, but it's not just at time zero or the initial state. It's at time zero at maybe 500 hours, 1,000 hours, and you continuously run that product. So the LM-80 is really more of a lifetime, but you do take photometric measurements. So you're doing sphere measurements where you're getting color coordinates, you're getting total luminous flux, but you're just tracking it multiple times over 6,000 hours or 9,000 hours or 10,000 hours, whatever. And then that collection of data is what's considered an LM-80 report.
So we'll circle back on that where, I guess just to put your head around it, we're at the luminaire level, the LM-79 report is kind of where that lives, and at the device or LED level is where the LM-80 information is being grabbed. But we're gonna circle back on that next week, and we'll spend some time talking about that as well as TM21 and how these pieces all kind of fit together. One other question, John, in terms of accreditation. I know we're NABLab certified, and I would guess as a manufacturer providing information to people like the DLC, there's probably some level of expectation that how do we validate that the data that we're providing is pristine in terms of maybe determining whether somebody gets a rebate or not based on the important data that's being delivered?
Sure. Yeah, they have to trust the data that's coming to us, and then how we do that as an internal lab is we are accredited, as you said, through NAVLAP, which is National Voluntary Laboratory Accreditation Program, and it's run by NIST, which is the government's standard organization. And they come in and audit us every 2 years on site, as well as we renew every year and have to do all kinds of activities, proficiency testing where we measure something, they measure it at their lab, and we compare. So there's a lot of work that goes into validating the way that we approach measuring our products, how we report on our products, the equipment we use, and that validation then provides, accreditation to our lab, and that level of rigor allows the DLC or Energy Star to take our data and know that it's not, manufacturer manipulated data. It is an accredited laboratory data that is useful and trustworthy.
Perfect. All right. Well, I don't see any other questions. Do you want to go to the last slide with the wrap-up slide, and I'll wrap up and close up shop? While we're doing that, just a reminder that there was some reference to TM30 in the presentation here. In earlier sessions, we actually did a two-part series around TM30. So if you missed that part and you have more interest in that topic, please feel free to look at our YouTube channel for that content. Looking forward to next week, we have, I should say for Friday, I should not go too fast, but on Friday then behind the scenes with building, networking, and controls commissioning. So that'll be our control session on Friday. Monday's design session will be focused on healthcare. And then, as I mentioned, John will be joining us again on Wednesday of next week, and we'll look at LM-80 and TM-21. So I do want to thank everybody for joining us. I want to thank John for preparing the content and presenting to the group. If you do have any questions for John, feel free to reach out to him directly. If you have any feedback on the sessions or topics, feel free to send me a note regarding that. And with that, I will thank everybody for their time and hopefully see you guys all on Friday. Thanks.